Now let's talk about instance variables. Instance variables are also known as instance attributes or data fields. All right. The formal syntax, we'll talk about the formal syntax. How do you declare an instance variable? Uh, and then we talk about the situation when instance variables are not assigned default values or when they are assigned default values. And then this session will end with a comparison between instance variables and local variables. Now let's start from the very beginning. Let's take a look at where are the instance variables. Okay, I've written a simple class called player. Right, this class is called player. It starts from here and it ends at line 64 at the bottom. And it contains, okay, remember what is in the class? Instance variables as well as methods. Okay, all these are methods. Several methods here. Okay, we'll talk about methods in a later session. Let's focus on instance variables here. Now, attributes or instance attributes, another name for instance variables. Okay, as I've previously mentioned, it is possible to have these two statements anywhere in the class. So in other words, I can do weird stuff like this, and your code can still compile. Um, and that is to be strongly discouraged. It's very bad practice. We'll try to put all the instance variable declarations right at the top within the class. Okay, so let's not talk about the methods first. I'm going to delete these special methods called constructors. Okay, delete them. Okay, I'm left with some other methods. Let me save it. Right, these are the two instance variables declared in the player class. Alright, let's take a look. This instance variable is called ID, called identification. This is the name of instance variable. The type ID is of type string. In other words, ID will store the address of a string object. ID is an object reference type variable. It will store an address or null. Alright, and this is what we call the accessibility modifier. Okay, let me go back to the former syntax. So this is how we declare an instance variable, okay, within the class, outside a method. The accessibility modifier, private or public. Actually, there are four categories of accessibility modifiers. Okay, for instance variables, but for this session, to keep things really simple, let's talk only about two. An instance variable can be either public or private. All right, public or private are what we call accessibility modifiers. They modify the accessibility of the instance variable. Now, for now, just keep it as private. Okay, there's a reason for that. Now the type. For the case of ID, type is a string. The variable name, of course, has to follow variable name rules. Okay, this cannot be a keyword. It should, by convention, start with a small letter. If you need, use camel casing. For example, let's say the name is called first name, camel casing. The first letter is lowercase. The first letter of the second word is uppercase. So it makes the word very easy to read. Okay. Class names start with a capital letter. Variable names, including instant variable names, start with a small letter. Constants or finals, all caps. Okay, not difficult to remember, very easy. Rules, these conventional rules are quite simple. Now here, same thing. We have the accessibility modifier, private. The type of the variable, int. Okay, Endurance stores a number, a whole number, and it's the name of the instance variable. So this class called player has got two instance variables. Now, why do we call them instance variables? Because they belong to an instance of player. Okay, recall the difference between a class and an instance, also known as an object. Instance means object. So we call these instance variables because every instance of player, okay, which is created from the player class using the new keyword, will have an ID and will have an endurance, and they are independent from other instances. So if I have two instances of player, the first instance of player has its own ID value and own endurance value. The second instance of player will have its own ID value and endurance value. Okay, these values may be different, may be the same, they're independent. Okay, it's like you have a value for your height, you have a value for your age. I have my value for height and I have my value for age, and we are both instances of the human class. Okay, if we look at a human class, is defined there: private double height, private double weight, something like that. All right. So now it's possible to actually initialize an instance variable. So this part here is optional. You can actually put a default value you want to. So I can do something like this: equals to some name, okay, equals to 80, for example. Now let's save this. Okay. By the way, to retrieve the value of ID and the value of endurance, I've got two getter methods. Where are they? Here are they. Get endurance, which returns the endurance as an int. Get ID, which returns the ID as a string. Okay. So I've written a class called player test, which contains a main method, which means that player test can run. On statement 4, I'm creating a new player object using the new keyword. I'm creating an instance of player. I store the address of that new instance in the variable called p1. Okay, and then on line 6, I'm going to call getID, which will return the value of ID. Okay, which belongs to that instance. Which instance? This instance of player. And I'm going to call getEndurance. It's going to return me the endurance, the value of endurance of this instance of player. Okay, I'm going to write more code here. I'm going to declare another. I'm going to create a second player instance, store the address in P2. Okay, I'm going to call its ID, get ID and get endurance. All right. Okay, let's save them and let's compile. Player test. Okay, and run it. Okay, realize that p1.getID returns the string some name. Okay, which means that the instance variable ID in p1 is some name. And of course, getEndurance returns 80. The same for player 2, the second instance. Now, why is that the case? Why is ID called storing the string some name and endurance storing the value 80? Because of this part. Okay, I'm assigning it a default value. Now, besides getEndurance and getID, there are methods called setEndurance and setID, the getter and setters, okay, which are used to change the value of instance variables. So let's modify code a bit. Okay, player test. So after creating player 2, let me call its setID method and pass in Peter. Okay, p2.setEndurance, and I'm going to pass in 70. Peter has few endurance points, and I'm going to call p2.getID, which should return Peter, p2.getEndurance, which should return 80. 70, right? And if I try to print the ID of P1 and the endurance of P1, okay, you realize that they are quite independent. Now I'm going to print some some dummy lines in between so that we can differentiate the output. So I'm going to compile player test again and run it. So let's trace output. Okay, this is the result of line number 5 and line number 6, which shows that P1's ID has a value of some name. Okay, and P1's endurance is 80. Okay, now these two statements are the result of line 12 and line 13. Okay, line 12 and line 13, these two statements here. Now this shows that P2's ID is Peter and P2's endurance is 70. All right. Now when I come back to P1 and I try to print P1's ID and endurance, you realize that it is still some name and 80. I'm trying to show that P1 and P2 are actually distinct. They are both referring to independent player objects. Each player object has its own ID value and endurance value, and they're independent. Okay, like what I mentioned just now, your height, you have a height value, I have a height value, and we are independent. My height value does not depend on yours and vice versa. Okay, but the fact that both of us are created from the human class or the human template, we have a height. Same thing here. Now, P1 and P2 are both created from the player class, and hence, both of them will have an ID and an endurance, okay, but they can have different values for the instance variables. Okay, so I was saying that an instance variable is usually declared as private. Let's talk about public and private in a separate session. And an instance variable usually represents internal data. Usually, they are not exposed to the external world, and that's why they are declared as private instead of public. All right. Each instance will have its own values for each instance variable. Okay, we have seen an example where there are two instances of player and they have their own, each player instance has their own values for their ID and endurance. Okay, let's move on to the second point. Instant variables can be assigned default values. I showed that, correct? I showed that here. In this example, after the declaration, I assign a default value to ID. After the declaration, I assign a default value to ID. The question is, what happens if no default value is assigned? Let's try. Okay, so I'm going to get rid of this optional part, the assignment part. I saved it. Okay, let me recompile player. Player is the only one which has changed. So player test wasn't changed, right? Okay, let me run it. So we realize that the ID of P1 is now and endurance of P1 is 0. Does that show something? Okay, it shows that instant variables are given default values if you don't explicitly assign a default value to it. Okay, for strings, the default value is now. ID is a string. For integers, the default value is 0. What about P2? Now P2, you realize that the output is Peter and 70, and that's because we actually call the setID method and the setEndurance method of P2 to assign values to ID and endurance. So that's why if we shift these two statements to between line 9 and 10, you will still get now and 0. Okay. So the question is, what happens if no default value is assigned? The answer is the default value will be automatically provided. Okay, and what is the default value provided is either now, okay, for object reference types such as strings or anything student, etc. Okay, or false for booleans, or 0, okay, for ints, um, or even doubles. Doubles you get 0, 0.0. Okay, and for chars, the default value for a char, okay, which is instance variable, is 0, not single quotation mark 0, single quotation mark, okay, but 0, really 0, as in the very first character in the ASCII table. So just remember, if default values are not assigned to instance variables, Java will give a default value now, false, or 0, or 0, 0.0, okay, depending on the type. So actually assignment is optional, all right? So I was saying that assignment, if you want to do explicit assignment, usually happens in a constructor. In other words, although it is possible for us to do this, okay, it's possible to give a default value during declaration of the instance variable. This initialization, this assignment of a default value explicitly is usually done in a constructor. What is a constructor? We will deal with that in a later session. Just keep that in mind. Okay, so it's not wrong, but usually people do this assignment of a explicit value in a constructor. Okay, and after we talk about constructors, you probably will understand why. Okay, now the last part here, instance variables versus local variables. I'll come back to this again when we talk about methods. Okay, because local variables are basically variables declared in a method. So when we talk about methods, you see an example of a local variable declared in a method. Do I have an example here? Let's check out the methods here. Not really. For example, let's say I have a method called heal. I declare a variable here, int temp equals to 0. This is a local variable. It is declared, this is a declaration, right? In a method. Compared to this one, ID is declared in a class, outside a method. So that is the difference by definition. Okay, ID is an instance variable, is declared in the class, outside a method. It belongs to an instance of the class. This is declared in a method. It's called a local variable. Alright, so what's the difference? The scopes are different. Local variables are temporary variables and you can only use them in a method. In other words, once the method returns, once you reach this line, okay, the explicit return statement, temp will be thrown away. So temp can be used from where it is declared on line 44. It can be used all the way to line 50. Once you reach line 50, temp is thrown away. The scope is until there, until line 50. Once you hit a return statement, that's it. Temp is thrown away. So that's very different compared to an instance variable, correct? Instance variable exists as long as the instance of player exists. So huge difference in utility as well. Okay, in utility, huge difference in scope and significance. Okay, local variables are generally temporary variables. Oh, I forgot to mention, this is an important point, which I'll mention again. These are all considered local variables. These are actually parameters, okay, method parameters. So additional endurance is actually a local variable, which can be used only within the heal method. So you can use in additional endurance from this opening curly brace all the way to the closing curly brace on line 48 of the method. Beyond that, additional endurance cannot be used. This variable cannot be used. Okay. Another important point is that local variables need to be explicitly initialized, unlike instance variables. Let me show an example of what I mean by that. Okay, let's say I have int temp and I try to use temp. I saved it. I just press Ctrl S and let's try to compile player. You realize that there will be a compilation error. It says on line 45, which is this statement, the variable temp might not have been initialized. And of course, they did not explain that local variables such as temp must be initialized before first use. Because compiler sees this statement and it does not know what should be in temp. Okay, if you just put something like equals to 0, and this will definitely result in a successful compilation. Right, although in this case it doesn't make sense. These two statements are really not useful here. So unlike instance variables, local variables must be initialized before first used. Okay, Java won't give them a default value. And local variables cannot have an accessibility modifier. Now instance variables have an accessibility modifier in front, private, public. Local variables cannot be declared with private or public in front. You get a compilation error. It does not make sense for a local variable to be private or public anyway. Okay, that's it for instance variables. In the next session, we will talk about methods.